Hi, Assalamualaikum warahmatullahi wabarakatuh. So, my name is Noamira Fasha binti Jamsuddin. Today, my team and I would like to present for assignment Ecs246 in topic incorporating fiber waste in sustainable concrete. So, we are choosing for fiberglass.
So we move to the next part, which is
So we
group
move to
member.
the next
So the
part,
first
which
is
is
Nur Amira
group
Fasha
member.
binti
So the
Shamsuddin,
first is
and the
Nur
second
Amira
one
Fasha
is
binti
Kamarul Iman
Shamsuddin,
bin
and
Kamarul
the
Bahrain.
second one is
The third
Kamarul
one
Iman
is
bin
Muhammad
Kamarul
Faiz
Bahrain.
Hafizi bin
The third
Yusof,
one is
and the last
Muhammad
one
Faiz
is
Hafizi
myself,
bin Yusof,
Aina
and
Najiha
the
binti
last one
Muhammad
is
Zaki.
myself, Aina Najiha binti Muhammad Zaki.
So, for the presentation outline, the first one is introduction, the second one is methodology, the third one is finding, the fourth is discussion, and next conclusion and reference. So now, I would like to present about the introduction. What is fiberglass? So fiberglass is a versatile composite material formed by embedding thin glass fiber within a resin matrix, typical composite of polyester, vinyl ester, and epoxy. This manufacturing process results in a material known for its outstanding properties. It boasts a high strength to weight ratio, making it both strong and lightweight, and it offers exceptional resistance to corrosion. Moreover, fiberglass provides superior electrical and thermal insulation, making it valuable in applications where these properties are critical. So, due to these advantageous characteristic, fiberglass find extensive use across various industries. In construction, it is prized for its durability and ability to withstand harsh environment conditions. Despite its many advantages, fiberglass does not come with challenges. Does come with challenges. It is considered expensive due to its complex manufacturing process and material. Moreover, recycling fiberglass presents difficulties, mainly because of separating the glass fiber from the resin matrix is a technically demanding and costly process. Nonetheless, its widespread adoption across critical sections underscore its importance and utility in modern manufacturing and construction.
Next up is methodology of how to produce fiberglass material. Our first step is open mold spray up, also known as chop and spray. This method uses a specialized gun outfitted with a bottle of resin to apply a pre-mixed spool fiberglass strand to a single-sided mold. In addition to its low cost, the main benefits of this method is that it is easier to produce parts that are of an irregular shape, as well as parts that are not meant to have an airtight or watertight seal or bear heavy loads and forces. The main drawback is that a part can only be produced with one smooth side, and the thickness can be less consistent than those produced by other methods, since the fiberglass is spray-on by hand. It can also lead to an inconsistent blend of resin and glass fibers, leaving porous or weak spots in the product. Hand rollers are used to squeeze out any air pockets, but if any air pockets are missed, this will also compromise the consistency and quality of the finished product. Next step is resin transfer molding, RTM. Use a composite of glass fibers and resin that is packed into a mold, with the fiberglass providing tensile strength and the resin contributing compressive strength to the finished product. To ensure a smooth, consistent finish on both sides of the object, all of the fiberglass fibers must be fully saturated with the resin. This is accomplished by layering glass sheets into a mold and then injecting the mold with resin. The two components are then compressed together by extreme force in a hydraulic press that ensures a perfect blend of resin-saturated glass. This method of construction is effective in developing dense, compact layers of fiberglass for objects that need to bear heavy loads or repeated high-force events, such as manhole covers. The drawback to this method come in the actual manufacturing process itself, which requires expensive tooling and a large hydraulic press to ensure that the two halves of the mold hold together effectively. For the third step is vacuum-assisted resin transfer molding, or VAC RTM. This evolutionary stage use a vacuum to pull rather than push the resin into the fiberglass to create a better seal without the need of an expensive hydraulic press. With something as simple as a pair of vice grip pliers used to securely clamp the two halves together. The finished walls also incredibly smooth, which makes it easier to attach things to it, while there are no holes or pores that can adversely affect sealing capabilities. The biggest challenge with this method is the simple fact that there is an absolute maximum amount of force that can be generated by a vacuum. This limits the amount of fiberglass that can be permitted by the resin, which restrict the load-bearing properties of the finished product and by extension the number of different products it can be used in. This process makes it ideal for parts like containment chambers. Last step is sheet molded compound (SMC). This recent fiberglass manufacturing combines between chop and spray and RTM methods. Its basis is a putty-type mixture of resin and chopped glass fibers that is produced in sheets that can be molded to meet the specific needs for density, length, and shape. The sheets are cut to the size and shape needed, then placed in a mold and pressed into shape. The result is a part that has the highest level of consistency available, making it the premier way to construct a high number of consistent parts over a short period of time. The main drawback goes back to the manufacturing process. A large and expensive hydraulic press is needed to shape the fiberglass sheets into a finished product. The mold that is placed into the press is a large, precision machined piece of steel that is made into the exact shape of the part to be pressed. The tool is then chrome plated for easy release from the press. The SMC process is ideal for high volume parts requiring consistent and detailed end result. That's all for the methodology of how to produce fiberglass material.
So now we would like to talk about the benefits of the product innovation. So the first one is economic and industrial impact. So fiberglass reduces long-term costs due to its durability and low maintenance need, leading to the saving compared to material like steel and wood. Its versatility supports various industries such as construction, automotive, and marine, improving efficiency and performance. So the next one is community environmental impacts. So fiberglass production impact communities in several ways. Environmental concern include the waste that doesn't break down the chemical pollution from resins, which can harm the soil and water. Noise from manufacturing can disturb nearby residents, and property value may drop, and quality of life can suffer due to pollution and noise. Although local jobs can boost the economy, following safety rules and involving the community can help reduce this negative impact and negative effects. And the last one is comparison with existing material. So fiberglass is lightly non-corrosive and easier to handle than steel. Though it may be less strong in some applications compared to wood, it is more durability and resistance to environmental damage, requiring less maintenance.
So this is the second part of findings, which is type of current research, development, and related to the product. There are 3 points of this type. So the first one is advanced manufacturing. So this one is actually research focused on 3D printing with fiberglass composites and developing higher performance sustainable resin system. The other one is sustainability efforts. Efforts include improving recycling method for fiberglass and developing bio-based resins to reduce environmental impact. So the last one is smart materials. Ongoing research includes embedding sensors within fiberglass composites to create smart materials for monitoring structural health and performance.
So here are the findings for third question, which is how the material is being used or possibility to be used in Malaysia. So here we are attached 2 points. First point is current uses. In Malaysia, fiberglass is used in first, construction, which is building materials, roofing, concrete reinforcement. Second, the marine industry, such as boathouse, marine components. And the third one is automotive, like vehicle parts, to reduce weight and improve fuel efficiency. For the second point, which is potential uses, potential application include first, renewable energy, like wind turbine blades, and the second one, infrastructure, such as bridge and water treatment facility, to enhance durability and reduce maintenance costs.
Next up is the discussion. There are many differences between carbon fiber and fiberglass, but we can put them in at least three categories, which is strength, weight, and rigidity. For strength, the strongest fiberglass can be stronger than steel and still be a lot lighter. That makes it great for certain applications. However, high quality carbon fiber is more than 20% stronger than the best fiberglass in the market. For weight, both materials provide a lot of advantages in terms of weight to strength performance. However, carbon fiber weighs about 70% less than fiberglass, and given its strength, manufacturers can use far less material when threading products made of carbon fiber. For rigidity, carbon fiber panels are known for being extremely rigid, while fiberglass is comparatively suppler, making it more suited for applications that emphasize flexibility over durability or structural integrity. As you can see, carbon fiber offers a lot more advantages over glass fiber products. It is lighter, stronger, and safer while offering a higher aesthetic value too. Kevlar is the lightest weight and toughest fabric type compared to fiberglass and carbon fiber because Kevlar is widely used in composite industry. It is used today as a fabric alone in bulletproof vests, impact and cut-resistant safety equipment, and used as a fire retardant. Kevlar has the highest benefit between being used as a fabric or composite. In composite form, Kevlar is used to produce structures that provide the best impact and abrasion resistance characteristics in comparison to other fibers. Kevlar fills the gap of stiffness between fiberglass and carbon fiber, while providing high-strength reinforcement. Kevlar can be difficult to cut and process unless the correct tools are used. Kevlar composite parts are almost always painted as they will degrade over time when exposed to UV radiation and sunlight. For its common applications such as high-performance aircraft and aerospace structures, body armor, surfboards, and motorsports protection.
Okay, the last part is conclusion. So, in conclusion, incorporating fiberglass waste into sustainable concrete presents a promising solution for both waste management and enhancing concrete properties. The study demonstrates the fiberglass reinforced concrete not only reduces environmental impact by repurposing waste, but also improves the strength and durability of the concrete. This innovative approach aligns with the growing demand for sustainable construction materials and highlights the potential for fiberglass waste to play a significant role in the future of green building practices. Continued research and development in this field will further solidify and availability and benefits of using fiber waste in sustainable construction, paving the way for more eco-friendly and resilient infrastructure.
So here are a few references where we collect data from, and the other references we are attached at full report.